should on the basis of Newton's law, but drops off at a rate which would bring it to zero at the speed of light. Now, Newton's relation between force, mass, and acceleration is simply a definition of force. So that it follows that because of this experimental result, either the mass must increase or the force must decrease. And there's no physical evidence to tell us which is correct. So Einstein simply made a choice. He guessed that the mass increases. Our theoretical development from our postulates leads to the conclusion that the effective force decreases. In either case, the mathematics comes out the same. At the time Einstein made his choice, there was nothing really to indicate that it made much difference which was which. But in the meantime, since we have come out with a result from our theoretical calculations that speeds in excess of light do exist, and that they do play a very important part in many physical phenomena, then it becomes necessary to go back and take another look at this situation. And when we do, we find this, that if it is the mass that increases, then the limit at the speed of light is absolute. Since the mass becomes infinite there, it's impossible to have any greater speed. But if it's the effective force that decreases, as our theoretical results indicate, then all that we have found from the experiment is that it is impossible to accelerate a particle to a speed greater than that of light by electromagnetic means, which our theory tells us anyway. And the important point there is that this does not preclude the acceleration of a particle or an atom or a star or a part of a galaxy to higher speeds by some other process, such as a violent explosion. It's the denial, it's the acceptance by the scientific community of Einstein's denial of the existence of speeds greater than that of light that has led to the trouble that science is now experiencing in what I've called the far-out regions. It's that error that has caused astronomy to far exceed science fiction, with all of its collapsed stars, its neutron stars, its black holes, its white holes, its wormholes. Well, I'm not making that up. That's in the literature. I noticed last week that quark stars have been added to the list. It's that conceptual error that's brought astronomy to that pretty pass, we might say. Our reciprocal system enables explaining all these things without those fantastic ideas. It brings the physics of the far-out regions down to the same simple and logical relationships that exist in the more familiar regions of our everyday experience. Now, I'll have to admit that maybe that isn't what you want. Maybe we're merely regarded as heartless destroyers of pleasant illusions and entertaining ideas. So be it. There's one happy thought I want to leave my associates with. And that is that even though we're doing the same thing that our predecessors did in the Middle Ages, we're challenging a thoroughly entrenched and established system of inventive thought. We're not likely to meet with the same fate as those people. We're not likely to get thrown in jail or burned at the stake. So thank you.